Everyone. I know most of you out there prefer short videos over a long marathon, right? So that's why I decided to split this video. Okay, I already given a solution, right? However, the solution I gave you guys, oh, by the way, this is the problem on hand. Exercise 8.3. The solution I gave you guys was incomplete, right? However, like I did it on purpose. Okay. So here's the deal. We have these student answers, right? Okay, and then we have correct answers at the bottom. Okay, so what we want to do is to display students in increasing order of their scores. Okay, so again, guys, this is one of those inefficient solutions. I just want to get it over with. Okay, I'm not concerned much about efficiency, nor am I concerned about effectiveness. Okay, so with that being said, let's get on to it. I'll start by creating an array of IDs. Okay, we have 8 students, so that array will have a size of 8, a length of 8. Another array will have student scores. Again, it has to have 8 scores. You know what? Let me populate my 2 arrays. Okay, so I'll start by going int r equals to 0, I less than IDs dot length I plus plus. Let me put curly brackets. Okay, so IDs at I is gonna be equals to I. Okay, so student 1 will have ID 1, student 4 will have ID 4. Okay, we probably need to typecast this, do we? Of course. Okay, now as for the scores, now student scores will be given by, you know what, it seems like we're gonna need a function that is responsible for giving us a score for a given student. So we're gonna call that function find score, and we will simply pass it the answers arrays, the keys, and then the ID, which is I. Okay, before I continue, now what we want to do is suppose that this, we already have this. No, let me just what data type should it return? Let's make it return byte. Find score. So it's gonna be what? Answers, and another char array called keys, then byte, student ID. Okay, return 1. Okay, We're gonna take care of that later. Okay, what? Why are we getting an error there? Really? Seems like I need to make I a byte, yeah. Okay, with that out of the way, suppose that our scores and IDs arrays are populated. Now the next step, which is the crucial one, is the one where we actually do the sorting. Oh, by the way, the approach I'll be using, the algorithm I'll use for sorting is called bubble sorts. However, we'll be applying it on a two-dimensional what? We'll be applying it on scores, okay, on a one-dimensional array called scores. Okay, so perhaps I should write that down. Bubble sort algorithm. Okay, so since we know that the number of elements in IDs is equals to number of elements in scores, we can do the following. Okay, bytes index is equals to so it's gonna be IDs. Wait, did I call my array that? Okay, so it's IDs dot length -1 is index greater than or equals to 0. Or matter of fact, we don't wanna go all the way. We're starting from right to left, so we need to leave the last element, okay, for the inner loop to use. Okay, so it's gonna be index minus. Of course, we need to typecast that to a byte. Okay, now what? As for the inner array, what we will be doing is to go in I is equals to 0 is I less than index. If that is the case, we increment I. Okay, and you guys feel free to do a research on bubble sorts, okay? How to sort an array using bubble sorts. So I will simply go if scores at I is greater than scores at I plus 1. If this is the case, then we know that we need to swipe. We need to do the swapping. We need to do the sorting. Okay. My apologies, you guys. You see, there are kids passing by here. There were kids passing by, okay? So score Z. Score Z I plus 1 is equals to score Z I. Go and score Z I. Sindo. Okay, watch it, kitchen man. Temp. It's temp score, not temp. Okay. Once I'm done swapping, I want to make sure that I do the same thing for the corresponding IDs on the IDs array. Okay. Now, temp ID is equal to IDs at I plus 1, and then IDs at I plus 1 has to be equals to IDs, and IDs at I has to be equals to temp ID. Yeah, you guys. That should do it. Once we're done doing that, we will need to display our students. So it's gonna be int I equals to 0 is I less than scores dot length I plus plus. Route dot print lin, of course. All our first. Oh gosh, that wasn't on purpose. I clicked this unintentionally. Okay, so let's just go student ID IDs at I. We're gonna leave a tab space and then go student school ZI. Yeah, you guys, that should do it for our main method, right? Now, how about the find score method? To be honest, this is the simplest method we probably have created before. Okay, just kidding. Okay, let's take care of it. First things first, we want to make sure that student ID is valid. So student ID has to be less than, if it is less than 0, or student ID is greater than so we want numbers 0, 1, 2, 3, 4 greater than 8. If this is the case, now what? I'll simply go bytes dot min, the minimum value of bytes data type. Okay, however, if that is not the case, then I'll do the following. You wanna create, you dumbass, what the heck are you making noise for? Okay, my niece was getting on my way. So grade 1 student, we want to grade a student basically, so we'll simply go correct count. We'll simply go int j equals 0. Is j less than what? Answers. Send him. Answers at student. Okay, so it answers. Oh damn! I just told these kids to get the fuck away. It seems like they can't, and I don't wanna be harsh or rude to them. Okay, so it's gonna be answers at y. It's j. Wait, as long as j is less than, okay, answers at answers at okay, so it's student ID dot length. This will do it. Okay, so it's gonna be j plus plus. Of course, we can replace this portion by keys dot length. However, just thought I should do something else. Okay, let's continue. Again, if answers at student ID then we want to put j there. If there is exactly equals to keys at that particular index, then we know a student got that question right. So we wanna increase count. This is pretty straightforward, right? Yeah, you guys, they should do it for this tutorial. And again, feel free to let me know your opinions, right? You don't want to keep your mouth shut and then spread, and you don't want to keep your mouth shut while spreading rumors about me that I'm uploading incorrect solutions. Because some guy the other day he said some of my solutions are wrong, but come on, I mean, perhaps there are solutions that are incorrect, but that is not the point. The point there is you want to see, for instance, on this video, you want to see how one can go about applying multi-dimensional arrays, or rather 2D arrays. Okay, so now that you see that we have a working solution and we've got sorted sorted students based on their score, I think we're good, you guys. You can verify yourself just by watching this. Okay, pause the video, check out this table and this array at the bottom, and see if I have a working solution or not. Cheers, you guys. I'm